Hey, in this video I will show you two ways we can represent graphs in MongoDB, and I'm using MongoDB 5 in case you are watching this from the future, the very far future. And to give us some sort of like vision where I am heading in this video, I'm trying to implement this comment section from Reddit. Someone can comment, someone can reply, you can reply to that reply, and so on. As you can see, there's like at least here 4 levels of nesting, 1, 2, 3, 4, and I guess you can. I don't know if there is like a limit to how much nesting you can have in Reddit, but I'm gonna assume there is no limit on that. And the way I'm gonna implement it, or at least one way, is this will be a document in my collection which will be called comments, for example, and this one won't be nested, but it will be in the same document, in the same collection, sorry, and with a reference field that points to this one. Hey, this comment, my parent is that comment. And now this comment, my parent is this comment. Now this comment, my parent is this comment. And how we can actually get the whole graph, I can start from here. Hey, search all the collection for documents that have a parent ID equal to mine. So this, like, I'm gonna get these two, for example. Now for these two, get all the documents from the same collection that have parent ID that points to me. Like now we will get this guy. Now from this, get me all the documents from the same collection that points to me. We will get this one. And if I started from the leaf of the graph, this one, I could do, following the same logic, go up to the root. Hey, get me all the collections that have that have an ID equal to the parent ID stored in me, and that's so on until I reach the root. And I'm gonna show you these this kind of implementation, and I'm just gonna call it reference graph because basically, just like I said, we will have all of these replies or comments. We will have them all here. Nothing is nested, but we'll have these parent ID like reference, and somehow we need to connect all of these references and build the graph. Mongo gives us something that allows us to do something like this. It's called the graphLookup aggregation. So I would recommend that you read about this because it feels a little bit repetitive if I just read everything here to you and then you go read it. It's just a waste of time. But basically, you will start with a single value using this start with field, and you will start by connecting it to a specific value and connecting it to another value. So for example, we start from the current ID from the root. Hey, match this ID with the parent ID. Now we will get 4 for each like iteration. Now we have these 4. Do the same thing until we have no results. That's basically it. I think in code it will make much more sense. So let's start actually by writing that. I'm gonna start with the root, and I need to get a graph of all of its children. And one note, graphLookup will actually return to you a flat list of the whole graph, so nothing is nested, or at least it's just the list. So to start, I'm gonna find my root like this. Now I need to add a graphLookup aggregation here. I'm gonna start with the reference, or the collection will be the reference graph. By the way, these names, like the reference graph and the flat graph, they just like they don't mean anything. I just add them here to make it easier. And start with like, hey, start with the current ID. This is the first result in the recursive search. Okay, this is the first result, which will be this object ID. And I'm gonna tell it, hey, always connect the ID with the parent ID. This is how you search on each level. Now, that's why I'm gonna add here ID and here parent ID. I hope it's clear. And by the way, you can add here array. You can start with like multiple values. You can do, yeah, there are so many things you can do. Read the documentation. And this is the name of the result. I'm gonna call it replies. This is the max depth. This is if you want to only go, for example, 3 depths. Anything more than that, ignore it. So, but I need the full graph for this example. And the depth field, since the returned result will be just a flat list, you need somehow to identify each document like depth if you need that, right? And this is what actually this allows you to do. So you can say, hey, depth, or you can name it anything you want, but this is actually not working because I think I need to remove this, yeah. Or I made a typo. Reference graph. Yeah, I made a typo. I made a typo somewhere. Yeah, I made a typo on the name of the collection. Anyway, and this last one, this is if you wanna like filter some of the retained documents. For example, if we have a soft delete feature, so I deleted, let's go back to the UI. I deleted this reply. Anything under it should not be retained in the result from the backend, right? So I have here these flags called deleted. If it's deleted, don't retain it, and don't retain its children. It's really easy. So only thing you have to do is delete it false. So get me all the deleted nodes. If at some point I reach like a node that have, for example, 100 children, and if this one is deleted, it won't be added to the result, and in the next iteration, these 100 like children of it won't be even like looked at. So because their parent ID does not match the previous retained result from the last iteration. Yeah, that's basically it. Now we have this list, but I don't think this is enough. Each one of them contains this depth, and you can name this anything you want. So I can name it X. It's totally fine. Here's the X. So, but calling it depth helps. But the issue here is, for example, the sixth element in the list containing the depth 0. You need somehow to sort them and maybe group them. So here what I'm gonna do, I need to sort them by depth. Then if the depth is equal, sort them by created at. And yeah, now to do this, if you think about it, this is a group inside of, like, this is a list, and inside of it we have groups by depth. So we need somehow to sort that. And to do this, not sure if this is the best way, I'm gonna unwind it. So if you have a much easier way, please tell me. So I'm gonna unwind the replies, and after that, let's actually sort the returned result. I hope you know what replies does, but basically it will just like spread down the list into multiple collections and in the same using the same key. I think you can change that, but does not matter in this example. I'm gonna now sort them by depth in ascending order. Now if the depth is equal, sort them by the created at. Now let's actually return them in like a specific format. We have two formats we can use. The first one, I mean, you can do whatever you want, but I'm gonna show you two formats we are gonna use. The first one, I need the data grouped by depth, and inside each group I need a list of the elements in that depth. Maybe this could be helpful in the front end, right? So let's actually do this. This is the first one. So I'm gonna group, I'm gonna use the depth as the ID for this group, and I'm gonna create a field called comments by depth, and I'm gonna push, or replies by depth, and I'm gonna push the returned result from replies. Sorry, this one should be replies depth. So I'm grouping them by the depth, and inside each group I'm having this array called replies by depth, which containing all the comments in that level. And let's actually test that if they are sorted by depth and by created at. So this one is created on the 2nd of January of depth 0. This one is created on the 3rd. This one created on the 6th, and so on until we reach the final one in the depth 0, which is created at this date, which comes after all of them. The same thing applies everywhere. So I think this makes it very easy for the front end to find a way to render this. I think it's very easy, or relatively easy, let's say. Now the other way, and by the way, everything I wrote could be found in the link in the description. There's a repo. And now I think the last thing, if you want to remove this underscore ID and give it maybe a meaningful name like depth, just use a project or set. Yeah, you can just use set. So underscore ID will be equal to 0. Remove it from the result, and or sorry, no, let's use project. I think it makes much more sense here. So ID 0, depth would be equal to the actual ID came from above. And comments will be equal, or sorry, replies will be equal to the value from this field. Yeah, I think this makes a little bit more sense. Could be useful in the front end as well if they are in this shape. So they are grouped by depth, and each depth have its own list. You could add as many abstractions as you want. You could convert this into a dictionary. Maybe that will make it easier without like adding so many loops and dynamic stuff. Yeah. Anyway, now the second thing I don't want this to be grouped like this. I need it to be returned to the original flat list that returns from the graph lookup, but sorted by the depth and the created at. I think that's one is it's easier. So after we did actually unwinding them, we unwinded them, we sorted them. Now in the group, the only thing will be different is here. So or this will be the same, but here I'm gonna change this. I'm gonna group them with the same value, which will end up having only a single document returned. So this will be body, will be referred to the body, and I will just tell you in a moment why this will work. And ID will point to the underscore ID. And as you can see, sorry, underscore ID. It works because all of these, after unwinding them, shares the same ID and body deleted and wrote true, because they all share it, right? Because this is the original shape of how we started. We have this array of replies, the whole graph, and they all share this after unwinding them, right? I think, yeah. Now we have this field. Sorry, we were here. We have this ID object. Now we need to just to fix how it looks like. So I'm gonna project. I'm just gonna do this. This will be replies, and sorry, this will be replies by depth. Yeah, or I think this I should call this just replies, right? So this will give us the same flat like list sorted by depth and by created at. As you can see, this is the 2nd of November, January, this is the 3rd, and so on. So yeah, these are two ways. This is how we can represent that in a flat graph. Again, the name is just like nonsense, but I think it's at least it helps me understand what I am doing. But yeah, this is like, it's just this case. It could be different in a different cases. Yeah. So another thing, another way to represent these kind of graphs is using something, I would call it flat graph. Maybe this is not the best way to call it, but yeah. Basically, instead of adding a document for each comment, you will nest them in a specific way that makes it easier on anybody using this data to like represent it on the front end, do some analytics on it or anything. You would do the following. This is the root document. Inside of it, we have two like different things from the previous example. We have this direct replies. These are references to the level, like one level down of the current node. So these are the level 1 directed childrens of this document. Okay, these are the direct replies. Let me show you in the front end. This is the root. These are the direct replies. So this is what this array represents. And it's just an array of references. Now in the replies, this is a dictionary where the key is the string representation of the object ID and the value is an actual document or an actual object. You don't have to use object IDs. but just make sure they are all the same type. You can use anything you want. Yeah, anyway, so we have this now key value dictionary, and all of these are replies under this document, no matter how nested they are. So some of them could be level 6, but they still all in the replies dictionary, like that, like this flat. You can access any node from this graph in constant time. This is the main catch here. No matter how nested it is, I can just access it. And the thing is, for sorting, we don't need to write any kind of a query. It's already sorted. So this is the direct replies manages the sorting aspect of this data structure. So you should definitely sort this in an ordered matter. So these should be ordered. I think this gives it like maybe a downside that it's a little bit annoying on the back end. Each time we add some CRUD operations on these kind of things, you need to manage the order. But again, if you are doing something like this is exact case, this could be a little bit like, it's fine. I'm not sure. It really depends on the case you are doing, but I'm just going to show you two ways. This is the second way. And let's talk about the front end, for example. If I want to render this, so hey, give me this root, and here is the full graph, all of that. All right, so I'm gonna start with the direct replies. I'm gonna display the direct like 3 replies under me. Now how do I get the body of this reply? It's easy. It's in a constant time through this dictionary. So I'm gonna just directly, okay, that's it. I'm gonna just display the information written here. Now the second one, I'm just gonna find it here. I'm gonna display the information, but notice we have another direct replies array of references here. So what the front end should do, should use this reference array and find this reference reply from the same dictionary. That's why they are all here, no matter how nested they are. And go again and display it. And again, if this one have another like replied direct replies, it will do the same thing, and forever. And as you can see, this representation of a graph, it can be summarized the following. We have only one dictionary that contains a key value. The key is unique, it's the ID of the node. The value is the node information. And for each node, we have a list of references, and these lists are sorted. So we can access, just map these references using the dictionary to the actual document and so on. Now we can build the graph. This is actually very, it could be very efficient on the front end. And actually, I got this idea from I forgot its name, but it's something from Redux. Normalizing the state. Yeah, it's something from Redux called, let's actually look it up here. Normalizing the state, Redux. I got this idea from here actually. Yeah, they will tell you, they will show you this nested data structure and how you can normalize it like this. So this is the ID, it points to this one. So in some cases, this actually could be very good for the performance. If you think about it, you don't need to query anything. Hey, I have the front end, I have this, give me the graph for this document. I will just go to the database, grab it, and the same document, and just return it. And that's it, no queries, nothing from the previous stuff that I showed you. But it is one catch here. Two catches. First thing, you need somehow to manage these to always be in the right place. That's number one. And you need to also manage these here. That's two. Okay, 3 catches. The 3 one is, what about soft delete, for example? I would say if you go for this one and you have soft delete, maybe it does not make sense. Maybe go to the previous representation or find another representation for your graph. But in case you are dealing with something like this and you have this soft delete feature, I don't want to return the deleted ones. It's not that hard. Let me show you an aggregation pipeline we can write. So first thing, let me start with this document. I'm gonna add a match. Object ID. Okay, now I need to filter these replies, right? So I'm gonna use the set stage. I'm gonna change the shape of the replies using object to array and give it the same key. This will return them to something that's similar to this one. So as you can see, each document or each object have been changed to key value object and containing this like key is the key, value is the value, v is the value. And just for testing purposes, I have this one marked as deleted. So instead of seeing six replies, we will see only 5 after we are done with this. Now, after we converted them to array, converted the dictionary into array, we need to actually filter it. So I'm gonna also use the set. Now, filter, the input will be the same array. The condition will be only get it if the is deleted is false. So I can reference the current element in the iteration using this dot v. Remember, this is how they are shaped. So dot deleted equal false. And now they are filtered. The only thing left to do, as you can see, now they are 5. They used to be 6. Now the only thing left to do is to convert them into the same dictionary. So I'm going to use again the set. Pretty sure someone can actually just put the whole aggregation into 2 instead of 4 stages into 2 stages. But I think that's easy to describe on camera. Like maybe in your, like you can do it on your own. So yeah, anyway, so I'm gonna now object to array and just give it, sorry, array to object, array, and that's it. So yeah, like it depends on your case at the end which one you would go to. But again, these kind of simple examples you can represent in MySQL and or Postgres. I prefer Postgres. Yeah. So now we need to talk about some performance issues. One thing is sometimes in Reddit you see some people like having a huge fight on the replies. And let's imagine we have, like, just for imaginary, like let's just say we have 1,000,000 replies on a specific comment. How we can deal with this kind of things? Remember, in Mongo we have a 60 megabyte limit on the document size, and again I think on the aggregation pipeline, I think aggregation pipeline size limit, I think 30 megabytes. 100 megabytes, but I think 1,000,000 like nested, or let's say in this shape. Like imagine if these are million, or even in the flat reference, imagine if the stage pipeline, like we have some comment that have 1,000,000 replies, and even in the graph lookup, they all will be returned. I guarantee to you this is more than 100 megabytes, because here I'm just putting the body. Sometimes the body could be an HTML. Like there are so many things, right? This could this is an issue if you have so much data. But again, it depends on your application. But anyway, one way we can fix that is, as you can see here in Reddit, they don't show you. Let me refresh. They don't show you the full graph when you first see the page. They will fetch some data, and as you can see, this one, like the whole the whole replies under it, it's hidden. You only have the count, and this count, I can guarantee to you, it's stored in the same place this comment is actually stored. So now when you click, they will fetch that. So this is the first thing. We don't need to fetch the whole graph at once. That's always a good thing to do. Don't retain the whole data. Now the second thing, this solves the aggregation pipeline issue, where it's the max limit is 100 megabytes. Don't retain the whole graph. Just filter it. Hey, filter the depth, only retain the first 2, for example. There's so many things to do there. I think it's doable and could be fixable. But the other thing is, in this case, like the flat graph, if this is 1,000,000, this actually reminds me of this pattern in MongoDB. It's called outlier pattern. Sometimes in your collection, you have this document that is like, it's being outlined based on some condition. For example, here they give you an example on box purchases. Like some books have 2 free purchases, but one of them has millions. Like why this one is stored in the same place as others? It will definitely reach, like, be more than 60 megabyte. And the way that they recommend you solve it is you have this has extra field on that document, and in the array, or in our case, in our dictionary, you don't store the whole million. You will store maybe the top 4 voted maybe replies, or maybe the top 100 replies, and anything extra you will store it in a different collection, and these will have a reference to this document that, hey, I belong to this guy here, and that's it. This is called the outlier pattern. And yeah, I actually used both of these two representations. I use this one on very simple things. It works, and it's very easy on the back end. I will just throw it down on the front end, and that's it. The only annoying thing was I have to manage these. I need to sort them correctly in each place. Now for this one, I actually also used it, and each time I write my aggregation pipeline, I will end up just putting using Node.js or Python. I will end up doing this data structure after the pipeline finishes. I will map it to this, then return it to the front end, because I found it in the front end. This is very good way to represent a graph. I'm like, this is my personal opinion. It's very easy when we need to render it dynamically using React or Angular. I liked it, but yeah. So again, with this one, I wanted to tell you something very important. Yes, okay, I remembered. The largest graph I dealt with used to have 3,000 nodes, and it was decent. The speed of the aggregation pipeline, the graphLookup pipeline, it's very decent. But the issue is, I had to add, I remember, indexes to make it decent. So adding index, in our case, you would add an index on the parent ID and the ID. This is like very crucial if you are dealing with like little bit large graphs. Add indexes; they will help you a lot. And the second thing is this, like these two models that we did, or representations, like cover this case, but there are so many cases where these kind of representations will completely fail, or maybe require so much work, and maybe that work will harm the performance. I'm not sure, but like there are so many things this will not cover. It's just simply graphs if you think about it, nothing more. And yeah, just keep that in mind. I remember, like, what if this graph could have references to nodes in another graph? And now when you fetch that data, you need to get your graph and, hey, reference that node from another graph. And when you reference that node, reference all its children and its children's children. And maybe one of them will have a reference to another graph. Like, you see, like this represented here won't be that easy. Like it will harm your performance. You will end up with so many graph lookups. Yeah, I hope what I'm saying is clear. And I actually wrote some notes about the things that I should speak about. I'm just double checking if there is anything I missed. The outliner, Redux, this is the nodes indexes. Soft delete, I showed you that. I showed you the two ways, the flat and the manual reference, the reference graph. Yeah, that's basically it. I hope it's useful. There will be a link in the description for all the things that I talked about, and the code also. Yeah, by the way, this is like maybe the 5th time I recorded this video. I still have no idea when it comes to recording videos. It's not easy. Yeah, bye.